tantalizing evidence that Mars may have once been green. And as yet, some instruments indicate that deep into the soil, there may as yet be life unseen. Yes, this is Greg Allison with Galactic Greg's coming to you on the 15th of April, 2021. In the wee hours thereof, time on deck is 0100 hours Central Daylight Time. Yes, 1 a.m. in the morning. So I won't post this until sometime later today. So have you got your taxes done yet? Thankfully, you now do them by the 17th of May. All right, all that said, wow. So what's happened is we have found evidence that Mars may have once had a reducing atmosphere, which it could not rust in. But we know the Mars today. The Mars we know and love today is a rusty red, a rusty, dusty red planet. But once it may not have been red, because it may have had a reducing atmosphere that would not permit rust. And not only may it not have been red, it might have actually been green, because the process that produces oxygen may have been photosynthesis, suggesting that life may have once flourished on Mars. Photosynthesis, green life. Indeed, Mars may have been a lush, well, maybe not so lush, but a green planet indeed. Maybe not for long, but long enough to create enough oxygen to make Mars an oxidizing planet. So, and in fact, it brings other questions to the fore. Was Mars actually the origin of life? Did life originate on Mars? The reason I ask that is that Mars, being a smaller planet than Earth, its surface may have cooled down sooner. As we know, there's life on Earth that goes back to about 3.6 billion years. It may be a fact that Mars may have cooled down much sooner. I mean, as soon as the rocks on Earth were cooled, it seems that life was here. So could life have started on Mars, been there earlier? And it could be that gave it a jump start for having photosynthesis. It took life on Earth about a half a billion years, about the same time that there was an atmosphere on Mars, to go from single microfossils to having photosynthesis. Photosynthesis is a very complex process. Having photosynthesis on a planet may have actually meant that you had cells capable of using the oxygen, because it was it's a very great opportunity for cellular life to take advantage of oxygen and to breathe that. So there may have been simple little bacterial animal life and plant life on Mars up to 3.5 billion years ago. Long time ago, right? But maybe, just maybe, that's where the life on Earth originated. We don't know that. I'm going to do a video real soon suggesting maybe life actually eventually originated on Venus. I'm going to return to that topic because in 1978, Pioneer probe found some other tantalizing evidence for life on Venus, other than phosphine. So let's get into Mars. Let's talk about Mars. In fact, we're going to share some articles. We're going to go there. And I will throw out a couple of other little interesting twists when it comes to Mars. So let's do some shares and let's go theirs. Or there. Bad English, but it rhymed. All right, here we are. Planetary scientists discovered that Mars underwent a great oxidation event billions of years ago. Carl Sagan's billions and billions of years. Just billions, not plural billions and billions. Both Earth and Mars currently have oxidizing environments, which says, that we have oxygen in our atmosphere, which allows things to rust. A reducing environment does not. See, at one time, now we're finding rocks, evidence of rocks on Mars that came from a period that the Martian atmosphere was reducing. See, some people thought, well, Mars was always this way, but now we're seeing a process which suggested that Mars went through a great oxidation event. So, my cursor, here it is. The transition of a reduced planet, which has no ability to make rust, no oxidizer, to an oxidized planet is referenced to as the Great Oxidation Event, or GOE. It's a central part of our planet's evolution, fundamentally linked to evolution of life right here. Yes, photosynthesis. It says we had a prevalence of photosynthesis that produced the oxygen that made our life possible. Is that what happened on Mars? Was it just chemical processes? But Mars went through a great oxidation event. It didn't happen all at once. Why? was Mars reducing and then switched to oxidation. But did the chemistry change or did something develop there? So that's the interesting enigma. And there's more enigmas. I'm going to show you some instruments readings from the Curiosity probe, which suggest just maybe, deep in the soils in certain locations on Mars, there still might be life, just possibly. So this is published in Nature Astronomy by a postgraduate student who's working on his doctoral degree, Jack Ching, okay, I won't get that correct, pardon me for murdering her name, and Dr. Joe Mikulášsky, okay, both of the Research Division, Earth and Planetary Sciences Laboratory for Space Research at LIU. And what they did is they used infrared remote sensing and spectrometry, and they measured the molecular vibration of materials on the Martian surface from orbit. So that's what it's saying. And with that, they were able to reveal mineralogy and geochemistry of ancient rocks, so they could see where it was weathered, through detailed comparisons of infrared remote sensing data and data collected from laboratories on Earth. They also used rocks from near China. So they were able to ground truth it with that. And I believe it's, there we go. Of course, we all know that Mars is cold and dry now, but 3.5 billion years ago, at least as recently as 3.7, so there's a little bit of difference in some of these articles. 3.7 billion years ago, Mars was warmer, wetter, had a thick atmosphere, temperatures kind of like on Earth. It had water, rivers, lakes, oceans, river channels, lakes, minerals that formed by the interaction of water. That's what our probes are finding there today. Our landers, I should say, the rovers. And scientists have used mathematical models to constrain the conditions of the Martian atmosphere. They concluded that greenhouse warming occurred. So Mars was kind of a nice place to be once upon a time. How about that? So they looked at this infrared spectrometry, the minerals exposed, weathered rock units, and they said they went to this volcanic rock in Hainan Island in southwest China to do the ground truthing. So there's thick sequences of basalt, similar to volcanic rocks on Mars. And they published all that applied clay science. So they're published in quite a few publications. And so this was Jia Qing's PhD project. And it was also, there's Assistant Professor Ryan McKenzie of the Research Division of Earth and Planetary Sciences. He's quite impressed by this. He said, this is a rather remarkable study with findings that will significantly impact how we understand the early evolution of terrestrial planets and their surface environments. The transition from reducing atmosphere on Earth about 2.5 billion years ago was only possible because of the existence of life, as oxygen is a waste product of metabolic processes like photosynthesis. So get this, he says 2.5 billion years ago, this was possible only because of the existence of life. Without microbes producing oxygen, it would not accumulate in our atmosphere and we cannot be here. Or at least this is what Dr. Ryan McKenzie says. Now, you're going to find some other people who would probably beg to differ with that, as always. PhDs who like to fight and argue. But this is highly intriguing, highly intriguing. So why did Mars go from being a reduced environment to suddenly becoming an oxidized environment? So this is a rather interesting case here. So let's go back here and look. Bing, on Earth. When did photosynthesis emerge on Earth? Well, about 2.8 billion years ago. Well, this was after Mars lost its atmosphere. We're going to go back to this. So it's, I want to say that Mars apparently perhaps had photosynthesis on its surface before Earth, but Earth was a big planet. It took Earth longer to cool down. Mars may have cooled down early. Mars lost its magnetosphere 4.2 billion years ago. Rock on Earth was still hot, too hot for life at that point. There was no life on Earth. So maybe Mars had a head start. That is quite possible. So it makes Mars a likely candidate for the origin of life in our solar system. And through meteoritic bombardment, some of that life might have got ejected from Mars and landed on Earth. Mars may have seeded Earth, and Mars may have been seeded by other sources. You know, there is this concept of panspermia, which I find very interesting. We'll go back to that. Hopefully I get Richard Hoover on my channel soon, who he likes to show pictures that look a whole lot like fossils and meteorites. That will be an entertaining discussion. I've got a video of him in the past, so we'll have to get an update from him. One of my earliest videos was of him, if you go back and look through my channel. Microfossils, perhaps the world's oldest, have biological characteristics. And how old are they? 3.4 billion years old. When did Mars lose its atmosphere? About 3.5 billion, maybe 3.7 billion years ago. And some of this life we're finding can exist in it looks like in a hibernation state if it's deprived for some time, perhaps on a meteorite drifting through the solar system before it falls into Earth's atmosphere. And apparently the interior of some of these meteorites do not get above the temperature that they would cook, even though the outside's a big fireball, because it's not that conductive. So it is just quite possible that some event could have knocked loose a big chunk of rock from Mars, and some of that might have made it to Earth, and microbes may have been seeded from Mars to Earth, because Mars cooled down sooner, maybe had more time to develop. And even Mars may have been seeded from other extraterrestrial sources, because it took, the cell is a very complex thing, very complex. So how did all even just the folding of proteins, forget DNA, just the folding of proteins is used inside the cell is incredibly complex to have just arisen spontaneously in such a short order of time into the great complexity you see in cells. But that's a whole nother story. Fact though is we are here. From whence did we come? Maybe we're all Martians. Maybe that's why we want to go to Mars. Maybe some people just want to return home. All right. So many of you may have heard of stromatolites. Stromatolites were formed from basically microbial mats, which cemented sand and other rocky materials as they formed these mats into layers. And they grew these funny looking, nodular looking big rocks. And they're believed to produce most of the oxygen in Earth's early atmosphere. Stromatolites today, you know, it's diatoms, plankton, plankton, algae, which are all diatoms. Diatoms have some very unique, interesting capabilities to been able to survive a long time, perhaps even out in space. And you can hear that from Richard Hoover. So stromatolites. Mars may not have had time for stromatolites, or maybe it did. Here we are on Mars. So we also know that Mars had some huge swings in temperature before it finally dried up as it is today. But guys, I'm about to show you something really interesting. Hold on your hats. Let's see if this is my next article. Got to wait on Zoom to let me get up to my tab. Zoom is causing me some issues here. There we go. Here we are. Here, you may have heard that there's some unusual cases of methane. That methane, trace amounts of methane exist at higher amounts than they should on Mars, and that methane has a certain fluctuation that don't quite match the rest of atmospheric gases. And some people have suggested that methane's a biomarker, and that maybe this suggests that there's still life on Mars. Well, guess what? The same kind of variations, they actually track with each other, exist for oxygen on Mars today. Yes, and how we find this out? From the spectral analysis at Mars, SAM. You know, it had an R in it, and that's almost Mars backwards. Should have worked on that acronym a little bit more and made it Mars backwards, but SAM sounds cool, SAM. So what they found is that this instrument, which was inside the belly of the Curiosity rover, took in air in the Gale crater where the Curiosity rover is moving through. That's its mission. And what they found, some interesting results, that of course the atmosphere is 95% CO2, 2.6% molecular nitrogen, which is the most common element in our atmosphere, 1.9% argon. It's 0.16% molecular oxygen. And of course, it's got 0.1% 6% carbon. Oh, by the way, this content of oxygen in the Martian atmosphere as a percentage is greater than the percentage of CO2 in the Earth's atmosphere today, which is 400 parts per million, which is far less. Okay, so let's go on down here. So the odd thing is of course, that what happens is the atmosphere changes with seasons on Mars. As the CO2 freezes out on the polar regions of Mars, the atmospheric pressure drops and the gas composition rises and falls with that cycle. But it does so by a certain percentage. But oxygen, check this out, guys. There's the Martian spring, summer, autumn, and winter. Oxygen, see, and here's what the normal gases do. So they expect these gases to, all of them, to track the same curve. But oxygen is different. It goes higher in the spring and summer and even lower in the winter, almost suggesting it's being produced and being consumed. Pretty much a similar curve to what's happening with methane on Mars. What's produced in it? It could be chemical reactions. Hey, maybe chemical reactions made Mars oxidizing planet. But all the people that look at Earth say, hey, it took photosynthesis to make so much, and we wouldn't be an oxidizing planet had it not been for photosynthesis, which suggests that maybe, just maybe, possibly there was life on Mars, and maybe even less so likely, but just maybe possibly, if you dig down deep under the soil in the Gale crater where Curiosity is running around, you might find something. If we had the right kind of instruments, there might be something living underneath the soil where they're below the level where all the radiation is so great, all the UV and everything else. Mars' surface is bathed in UV. But on the surface, you have, perchlorates and hydrogen peroxide, which it's not friendly to life. But maybe a little deeper, it might be better. Of course, this means also might be microbes. And you go, oh my gosh, those microbes might infect us and kill us. Well, they're not living off of our kind of tissues right now. They're not adapted to that. So probably it wouldn't be the case. It's not so much bacteria in the world today. And so that bacteria probably comes to Earth every now and then anyway. And vice versa. May have came from Earth due to local within the solar system panspermia, which is probably more, viable in terms of cells surviving. But some cells, it seemed, some research could last a long time in a suspended animation type state when they're dehydrated and frozen. So here we go, guys. This is highly intriguing. Does this suggest that there's still life on Mars today? Hey, just a question. It's a long shot. I admit it. Don't go out and say Greg Allison said that Mars is alive, that Mars was alive. Hey, these are possibilities. I'm asking a question. Was Mars once green? Well, there's good indications it may have been. And is there still life down under the soil today? Well, maybe. Just maybe. I'm not saying it is. But, these are interesting phenomenologies here. So I'm not going to go into all this. I'm not going to read it. I'm just pointing out the interesting aspects of it. So, death by magnetic field, the story of Mars' atmosphere. So we know Mars lost its atmosphere. Here it said that Mars had an atmosphere capable of producing life for water, oceans for half a billion years, 500 million. Around 3.7 billion years ago, it started losing it pretty significantly. But the loss started when the magnetic field died 4.2 billion years ago. So Mars cooled down relatively fast, with the molten core just stopped long ago. So since Mars is cooling down so fast, that's why it may have been more amenable to life before Earth. And so Mars is cold, desolate. Mars used to have rivers, lakes. Here it says with a lot of life. Well, he can't prove that, but that's an interesting to have in here. So he really means death by magnetic field. Loss of magnetic field cost Mars atmosphere. And if it had life, it cost Mars a lot of life. So maybe, just possibly deep in some soils. And there's been some people that have suggested there might still be microbes deep under those soils to this day. And we're seeing some suggestive hints. It just might be possible. just maybe. So here they're talking about Maven, findings of Maven. But, you know, guys, think about this. It took roughly 500 million years for life on Earth to produce oxygen. Scientists have confirmed that 3.4 billion years ago there was life, but we started producing on Earth, but we started producing the oxygen before that. So I'm trying to get back up to my other tabs. When the photosynthesis start 2.8 billion years ago. So 2.8 billion years ago from 3.4. So that's roughly 600 million years from first bacteria to evidence that we had photosynthesis. And maybe Mars got there a little faster. But how long was Mars actually capable of supporting life? Earth's about 4.5 billion years ago old, they believe. Maybe Mars is just a little bit, the solar system's about that age. Mars might be just in that range. So maybe, just maybe Mars has got something going on. And here's the Curiosity probe that we're talking about. You know, it's about the size of a small car. It's an RTG, radiothermal isotope generator. So it's run by nuclear power, basically. This is the fuel pellet inside of it that gives it the power that can run it for years. And it landed on Mars in 2012. So it's had a good long run through the Gale crater, hopefully heading to the central peak there to climb that mountain. So maybe we'll have some good findings when it gets there. So, alrighty, guys. One last thing. If you hadn't already found, if you're not subscribed to my channel, please subscribe, bang the up notification bell, and click all. And you can join me. You can come in here and go through my Mars habitat concept. Yeah, this is my concept for habitat on Mars. It's fleshed out by a friend named Michael Laurie. He did this work in a simulator called Kylie. You can come to this video and check that out. It's very interesting how we might live on Mars in the future. And if you hit videos, you can find all of my videos. You go back all the way to the beginning, or if you click oldest, it will come up as one of the older videos. Let's go way down here. Fossils from space. Now, this is Richard Hoover here. Very interesting presentation. I'll try to get an update from him really soon. But hey, I have a lot of fun with some of these videos. Check them out. Hey, and even Venus. Life on Venus. Yeah, I'm going to return to that topic real soon, like maybe in just a few days, day or two even possibly, because there's interesting findings there from the 1978 Pioneer probe. And hey, I'm going to do an update on my Venus colony. I'm going to do a series of updates on that. And of course, I'll keep talking to you about, you know, Starship, SpaceX, SLS, space station, commercial space stations, Axiom, other prospects for planets that may have life, some near to us. There's a lot of interesting news out there. I'm going to keep bringing you some of this. So we're going to have fun on this channel. So please stay tuned. Recommend this channel to your friends. And if you want to support this channel, check the links below from my sister channel, Galactic Griggs, because that's a good way to support this channel too. And by the way, hey, it's planting season for those of you that garden. It might be a good, you know, if you don't live on Mars, you need some gardening skills. Did you ever see The Martian? Yeah, it'll serve you well to garden. So get started now, learn how to do it. So there you go. And now's the time to plant. So go to my links to True Leaf Market, check below. All right, I'm not going to go all in that. But anyway, so ladies and gentlemen, hey, hello, I'm back. Oh, yeah. A good friend, Ben Houston. Ben Houston made these on a 3D printer for me. 2 starships. In a future video, I'm going to show you how these can float, actually float, yeah, without a balloon supporting them, in the atmosphere of Mars. Yeah, they actually would, if you don't take Martian atmosphere in once you burn the fuel up. And how, when you link them in a refueling configuration, you could use them as a strong back to build a platform 300 foot in diameter, beginning of my Martian habitats. So I've got 2 of these. I'm going to show you this stuff, and not too distant future. Ben made me a lot of other fun toys. You know, some chess pieces based on rockets. Our Vostok rocket that Yuri Gagarin rode in. Yeah, so cool stuff, cool stuff. Got Soyuz and many things here. So and a lot of little neat chest pieces. Ben Houston. Yeah, we all know the Soyuz. Russian N-1 rocket. Y'all heard me talk about that, how it blew up so many times. I've said quite a bit about that. And we just had Yuri's night, so that's what my thing was. Here's what Yuri flew up in. Vostok 1. Yeah, Yuri's night was just a couple nights ago, and that's what my latest video from Mars is from Yuri's night. Guys, appreciate y'all for watching, and have an awesome weekend coming up, and hopefully I can get back and do another video too before then.